Hello, welcome back again to Omega Virtual Learning. Today's lesson is on bounds, and we'll be talking to you about how to calculate upper and lower bounds and how to express bounds error interval. I welcome all new viewers to this channel, and also special welcome to old viewers as well. Hope you find this channel educative. If a measurement is made correct to a given unit, then true value lies half a unit below and half a unit above the measurement. For example, if 12 is correct to the nearest unit, you need to find out the possible numbers below 12 that could be corrected to 12, and possible numbers above that could also be corrected or rounded down to 12. Now, since there are several numbers above and below, all we need to know is the least number, and because we said it lies half a unit below, we take 0.5 from 12, and 11.5 becomes the least number, which we call the upper bound, or the smallest possible value, and 0.5 above 12.5 becomes the biggest, or the upper bound, or the largest possible value. So we're saying that the mod 12 lies halfway between 11.5 and 12.5. And to express the error interval, we use this inequality to express it. And we are saying 12 will be between 11.5 and closest to 12.5. I will talk more of error interval during the latter part of the lesson. The only information I want to take from here to the next slide is that our number must be halfway between the boundaries. So how do we create a rule? Since the number is halfway, you always go by what is said as the rule, because it says that we are supposed to write 5 and 67, which are all measured to the nearest unit. So the key word is what? Nearest unit. And the unit is 1, so to create a rule, we divide 1 by 2. So our rule is plus or minus 0.5 to create the lower and the upper bound. So the lower bound for 5 will be 4.5. Upper bound for 5 will be 5.5. Lower bound for 7 similarly will be 66.5 for 67. And upper bound for 67 will be 67.5, all to the nearest unit. Now, what if these measurements are done correct to the nearest 1 decimal place? So, 1 decimal place, the value for 1 decimal place is 0.1. So to create the rule, you take 0.1 and halfway we divide it by 2. So which means our rule will now be plus or minus 0.05. So lower bound for 6.8 is 6.75. Upper bound 6.85. Similarly, lower bound for 14 is 13.95, and upper bound is 14.05. So we always divide the given approximation clue by 2 to create a rule. Nearest 10. So the approximation clue here is nearest 10. So we take 10 and we divide it by 2 to create the upper and lower bound for these two numbers. So we're going to be plus or minus 5. So 1040, lower bound will be 1035. Upper bound 1045. Similarly, 20, lower bound is 15 and upper bound is 25. And in all, if you check, the given number lies exactly halfway. The given number lies exactly halfway. That's one way of checking your answers. Now, what if it is any other given units? So, for example, here, we're supposed to write the upper and lower bound for 11 and 7.9, which are all quantities measured to the nearest 0.5. The clue is 0.5. So we take the 0.5, create halfway of it by dividing it by 2. So our rule now becomes plus or minus 0.25. So lower bound for 11 is 10.75. Upper bound for 11, 11.25. Similarly, all 0.5 we divide it by 2 7.9 lower bound becomes 7.65. 7.9 upper bound, 8.15. So just remember the rule. Use the approximation clue and divide it by 2 to create the rule. Take away from the given number the rule. You take the rule from the given number to get the lower bound. Add the rule to the given number to create the upper bound. Now, when it comes to significant figures, it's more or less the same as what we did before. But what we need to pay attention here is the place value of the said significant figure. We use, to get the clue of the number to use, we take this place value of the said significant figure. So for example, we want to write the upper and lower bound for 48 and 4.6. They are all measured to 2 significant figures. So check the second significant figure. Second significant figure is 8, and place value of 8 is unit. So we're going to take a unit and divide it by 2. So our rule now becomes 0.5 because 8 in 48 is in the unit column, which is 1. So lower bound will be 4.75, upper bound will be 48.5. Now, second significant figure for 4.6 is 6. 6 place value of 6 is 0.1. It's in the 10th column, 0.1. So we take 0.1 and divide it by 2. So our rule will be plus or minus 0.5 because 6 in 4.6 is in the 10th column, which is 0.1. So lower bound will be 4.55. You just work it out. Upper bound 4.65. So just remember the rule for significant figures. It's similar to what we did, except that you use the place value of the said significant figure. What is an error interval? A number y is rounded to the nearest 1 decimal place. The result is 5. Write the error interval of y. Okay, so the result is 5. What we need to understand is that because it says 1 decimal place, the approximation clue here says what? 1 decimal place, which is 0.1, divided by 2. So we use this to create the lower and upper bound, which means that the lower bound will be 5 minus 0.05, that's 4.95. And the upper bound will be 5.5. So 5 will lie between 4.95, sorry. Okay, so since this is 4.95.1, we have 4.95 as the lower bound and 5.05 as the upper bound. So this is the error interval, and using inequality, this is what is supposed to be written. Remember, the number gets closest to 5.05. It can never be equal to that. So you need to be very careful about the inequality symbol that you use. So the error interval for this question is 4.95 to 5.05. And you will know that all these numbers, when you round it to 1 decimal place, the value will definitely become 5. Let's look at another example. A number x is rounded to the nearest 10, and the result is 20. Write the error interval of x. Okay, so the clue is nearest 10. So nearest 10, we take nearest 10 and divide by 2. So lower bound will be 15 and upper bound will be 25. So we create our rule. So that's the error interval. So this is how you should quote the error interval. And as you realize, if you round the nearest 10, you realize that this will become 20. This will become closest, because this cannot be exactly 25. So anything closest to 24.1, 24.2, closest to 25, that's what this is all about. Note, you do not use equal sign on this side. That brings us to the end of lesson 1. Watch out for lesson 2, where we do more calculation involving bounds.